This is the first part of a discussion about CORL 2023, the conference on robot learning that happened in Atlanta earlier in November. I'm going to start with, I think, the biggest takeaway, or what I found most interesting, is the comments that Sergey Levine made in the large data panel. And he said that it is worth thinking about robotics sort of in an implicit way, like what if we had a bunch of embodied intelligent things out there working, and we could maybe build data sets on what we observe from them, and then sort of build on that and learn from that and develop. So accelerate evolution of embodied intelligence. This is how I would summarize it. And Levine talks about this, and he also talks about the bootstrapping problem. I think, to me, that is the most interesting thing. I'm going to discuss the conference in more detailed way, probably a couple of parts necessary here, but this to me is the biggest idea. So I want to dedicate this episode just on that particular idea. This is not even on podcast. It's November 24, 2023. This is Krim Delco. Since the last update, we are down 1.8%. The market's up half a percent. We're for the year, we're up 105.7%. The market is up 18.7%. We're outperforming by 87%. So CORL 2023 took place early November in Atlanta, and it's a conference on robot learning. So there's a lot of different topics being discussed. I'm going to focus in this episode on my most interesting, most important takeaway, and that's Sergey Levine's comments on the way he'd like to think. I'm not sure he's doing that right now, but that's a different conversation. Let's talk about what he said. He said that we should be thinking as scientists already anticipating a large fleet of robots that is out there working, and we should build models, data collection technologies, benchmarks, all the things necessary to take advantage of a data set like that, and then use that as a next level learning, and so on and so forth. Now, he's also mentioning the bootstrapping problem, because right now there are no robots out there at scale as a fleet. Today, robotics is a relatively bespoke research field where you have research labs all over the world working with robots in their basement. Robots are difficult. I walk around a lot at the computer science department at Stanford, and I see people working with robots. These are 1-2 arm type things going around. They break, they need to be fixed, parts are expensive. Code is difficult, cumbersome to write. Operating systems are available, but some of them open source, some of them closed source, all that stuff. There's nothing really, this is not comparable to, let's say, computers and the internet. And I think robotics is sort of in the 1970s of the PC industry, right? We have these bespoke systems, a bunch of people trying to do this, trying to do that. Now, having said that, I'm going to finish this episode with my conclusion, and I want to just anticipate that, because I believe that there's one company out there that has real robots at scale, and that is Tesla, both on the car side and also hopefully soon on the humanoid side. And this is actually the approach that is necessary. We have low cost approach towards robotics, because we need scale, and cost is obviously inversely correlated to scale. So you can't have a large robot fleet with expensive parts that break all the time. That's not going to work. So Tesla, to me, is the solution, and I'm going to discuss this hopefully soon with the Tesla either IR team, or maybe even with their engineers if there is another AI day. But the idea is really, if you think about it, fundamentally, the way I think about this is the following. So I think that we have, and now I'm paraphrasing Sergey Levine. So let me just put this out there, so I don't have to say it all the time. All these ideas are based on Levine, so I don't want to plagiarize anything, but I do agree with him. So I'm going to now just talk about as if I think, I agree with him, and it's inspired by him, and some of the thoughts are mine, some are his. But let's just keep talking about what I think. So what I think is we need to think about a large fleet of robots that can have certain skills and that can learn to do other skills based on that. And then we have a larger fleet of robots that then can generate new types of data that can be used to learn even more, and so on and so forth. Now, this is sort of a bootstrapping method, which is really how AI has evolved, or whatever we consider AI so far. That's how it's evolved. We had the internet creating all the data, human input, either text or visual, that was trained first on supervised learning in the early days, and later on unsupervised learning, and recently on large language models or transformer architectures, which is a tokenized model that learns itself attention and then has the ability to generalize across what it's seen. To paraphrase Andrej Karpathy, who just recently had a very good 1-hour video about sort of the foundation of large language models, he says that the transformer architecture is really kind of like a compression algorithm that compresses the internet about, I think, about 100x in terms of data, and then is able to predict from that compression whatever information needs to be extracted from the internet. So in other words, if I prompt something, if I prompt, let's say, give me the best coffee shops in Tahoe City, that is information that I'm literally asking from the internet. And because I have, let's say 200 gigabyte type parameter parameters of the size of about 200 gigabyte that were stored based on training a transformer model on the internet, I now have compressed knowledge about the best coffee shop potentially in Tahoe City. And the way the actual translation works is really, it predicts the next word. And I don't want to talk too much about large language models here. Let's get back to this idea that we could have a bootstrapping process similar to that we had with large language models with robots. What we need, though, is we need a bunch of robots out there, a fleet of robots that works, that collects data, sensor data, and that is a little bit expensive right now. That's the problem. So we don't have a lot of robots working, and the reason it's expensive, it's the robots themselves are expensive. It's also expensive in a sort of opportunity cost way. If I really want to put a robot in my kitchen to do the dishes, well, it better be good and fast, because otherwise I'm better off just using a human. So there's this competition between humans and robots in most tasks, and it's going to be difficult to bootstrap that. This is the other point Levine made. We need to find a way to bootstrap that. In my opinion, that's an economics problem, because it is mainly in embodied intelligence, a competition between embodied intelligence and humans. And I'm not going to talk about sort of the problem of losing jobs and all that. Let's just assume we want to replace humans with robots. And it's happening in some cases. For example, in the self-driving car, we're trying to replace the driver with a robot. So there we can see it really well playing. And the more the car drives by itself, the more it collects data. Now, it does also collect data from the human, in particular in the Tesla model, which is using sort of a mix of behavioral cloning, imitation learning, and supervised learning, unsupervised learning, all kinds of learnings. But the point there is that we drive the car, and the car sees what the human does and then learns from the human. Then the car drives itself. Then the human intervenes sometimes. That would be sort of human inspired learning. And we have a shadow mode that is supposed to do that. So let's say the car drives by itself in shadow mode, and then the human drives, right? And this shadow mode, which is the car sort of pretends to be driving itself, even though the human drives, and the car pretends, okay, this is what I would do, this is what I would do. And whenever those things don't match, so whenever the car does something that whenever the human does something that the car would not have predicted, that is sort of a case where then the car can learn from the human, or vice versa, of course, if the human makes a mistake. So that's kind of the model that Tesla is using. And the idea here is that we have this large data set of robots driving around, and we also have the ability to collect the data. We have the ability to collect, let's say, ambient data and passive data. Passive data being that the car drives on the road, and there's, let's say, rain falling, and there's lights on the side, and there's a stop light, and all kinds of stuff around the scene that might not be directly important maybe for the driving task, but who knows? And that's where, in my opinion, the idea of and this is sort of where I want to take this now. This is not my own conclusion. This is not based on anything that was said at CORL 2023, at least not directly. I think that there is a room for a transformer-based model in robotics, not necessarily language-based, but token-based, that we sort of express our environment in tokens, and then learn the environment, very similar to what large language models are doing with language. So this is, in my opinion, a possibility. And I think Dieter Fox, in one of his papers that I'm going to discuss in more detail, talks about this. So we have this unified robot description format, URDF, and the transformer's idea is very similar. It compresses the environment into weights, and then rebuilds the URDF every time in every epoch, or in every so let's say if an epoch is 50 milliseconds, every 50 milliseconds it rebuilds that based on where the robot is right now. And that could be a way to potentially build a generalizable large-scale model for robots that then can infer from the environment what they're supposed to be doing, and therefore, in a sense, start becoming intelligent embodied beings. But we need something to start with, right? And this is the key. We need some fleet of robots that starts doing something, and very similar to the Tesla example. And this is really where I want to go here. If I had the chance to talk to Tesla engineers about this, I would ask them, look, if you are, first of all, are you building the humanoid robot really as a bootstrap to learn more, to get better at robotics? Is that number one? Is that the goal? Number two, if so, how are you thinking about model, data collection, benchmarking, because we want to have benchmarks, right? ImageNet is the most famous one, and we have, let's say, the attention's all you need paper is really the benchmark for transformer models. So we have good examples of benchmarks that have been used as a base for the community to build on top and really advance the field. So how is that here? Let's say if we have hundreds of thousands of humanoid robots working in Tesla factories as embodied intelligent beings. So that means they're not just going, screwing a screw, or hammering a hammer, or cleaning a floor. They are doing more than that. They're moving around the environment, executing tasks that they're given based on the environment, and adapting to the environment. This would be my biggest caveat here. They have to be adapting to the environment, because if they don't, there isn't really much learning, right? Then we're back to KUKA or Fanuc robots. That's fine, we already have them, but there's no point of collecting their data, because we can predict what they're going to do. So what I want to see is how much of a daily activity of the humanoid robot can I predict in advance? If the answer is 100%, then that's not embodied intelligence. If the answer is 50%, then yes, because I can probably predict about 50% of the activity of a human in a factory. Maybe not exactly the trajectory, but most of the big picture tasks that they're going to do, I can say they're going to spend 2 hours doing X and then Y, and so on and so forth. So I think that's kind of the question we have to ask. Okay, how much of the activity of the robot can I predict? And if the answer is, let's say, less than 50%, then that is really embodied intelligence, because that means the robot's adapting. So I would say that's a very important caveat in this conversation. So to summarize, CORL 2023, my first part here, This is the first part of the conversation, and I think I just want to really bring across the most important takeaway I have, which is Sergey Levine's comments about the idea that we have a large robot fleet that is working in an adaptive way. So with the intelligence to adapt the environment, we collect data, we benchmark, we build a data engine for that, and we learn from that, and then we might or might not build foundation models based on that. That is a different conversation. But what we want to do is collect the data and do something with it, probably in an unsupervised way, just the way the community is going these days. That's probably going to be the model that's going to be used. And we learn from there and then sort of build the foundation for the next generation of robots. And that to me is really a very promising path. And finally, the bootstrapping problem is a real problem, and Tesla is on the verge of solving that problem with the humanoid robot. In fact, also with the car, because what Tesla is doing, if you think about it, what the car is a robot, and it's a low-cost robot. That's key. Low cost, of course, not in the sense that it's cheap. It's not cheap. Model X's and Y's and 3's are not cheap, but they're incredibly good money, value for money, and that means that they can be scaled. People will buy these things. And the same applies to the humanoid robot. Musk has already spoken about the cost of actuators, cost of materials. We need materials that can that can fall all the time without breaking. So there's a lot of material science involved. A lot of the robotics problem, in my opinion, is a material science problem that goes also to the question of tactical sensing and things like that. But you can't have a robot that when it falls down, you need 2 weeks to fix it and thousands of dollars of repair. It has to be flexible in that sense too. That's sort of the direction that I'm going to keep thinking about, hopefully talk to Tesla about, and also potentially see other companies that are in that field. Thank you.